Hello everyone, welcome to our next lesson in Unit 2 on functions. Today we're going to look at something called composite functions. What do we mean by composite functions? Well, what if you had two functions such as, let me just show you some simple cases. What if you had f of x equals x plus 1? And what if you had another function g of x? All right, so it's just a different name. What if this was, say, just x squared? All right. Now, if I asked you to work out something like f of 2, what does that mean you're supposed to do? What is that asking you to do? Well, it's telling you to look at the function f, which is the first one. That's its name. And wherever you see an x, you replace that x with a 2. What if I said, what is g of negative 3? What does that mean to do? Well, it means you look at the function called g, and that's the second one. And wherever you see an x, you replace the x with negative 3. You would plug it into right here for your x squared. And I think you get back a positive 9. Well, that's pretty straightforward. There's nothing tricky about that. You've done that before. But now, something else you've done before, and you may not realize it, but one of the examples you did back when we looked at function notation was instead of replacing x with a number, you actually replace it with another expression. So what do you think this means? What if I said f of g of x? Now, what in the world does that mean? What are you supposed to do there? Well, if that was a 7 instead of g of x, you'd put a 7 in for x right there, wouldn't you? That's what you would do. Well, you kind of do that here now. What you do is you look at the function f, and everywhere in f where you see an x, and there it is right there, you replace that x with g of x, which in our case is x squared. So that would be the same thing as f of x squared, and that becomes okay, well, there's where your x was. So you replace that with x squared and add 1. And so here's your answer, x squared plus 1. That's what we call the composition of functions. Okay? Now, there's a couple of ways it can be written. F of g of x means you put g into f. You sometimes see that written like this, an f, and then a small circle, and then a g. So it means exactly the same thing as f of g of x. You can also do this. You could also find g of f of x. Now that's kind of the opposite, but what it means is you take your function g, and wherever there's an x in your function g, you replace it with whatever f of x is. And that can also be written as g of f of x. All right? It's pretty straightforward, very simple. One thing they note right here, and it's something that's very important for you to know, f of g of x, in other words, where you put g into f, is not usually the same thing as g of f of x, where you put f into g. They're usually different, okay? Here's some examples. Let's try these. Okay, now the first one, A, says find f of g of x. Now, if you wanted to, you could write that as f and then a bracket, and then g of x inside the brackets. It means the same thing, okay? So, what that means is, look at your function f, and here's your function f. All right? Wherever you see an x there, by golly, I see an x right there. Look, x is only there once. You replace that x with g of x. So basically, x squared plus 1 goes in right there. So in other words, you have 2 multiplied by, and here's your brackets now. I put brackets wherever I saw an x, you see. X squared plus 1, and then minus 3. So there, see what I did? I put g into f. And now I just simplify this, of course, right? So that will become 2 multiplied by x squared. Well, that's 2x squared. And 2 times plus 1 is plus 2. And then the minus 3 was outside. And so look at what you get. You just get 2x squared minus 1. That's the composite function. That is the composite function. Now the next part says find g of f of x. Again, if you wanted to, you could write that as g of f of x. And so what you would do now is the opposite, excuse me, the opposite of what you did the first time. Now, think of g as the outside function, so you're basically going to write down x squared plus 1. Okay, let me put down my bracket, something squared plus 1. There's g. But into that, I'll replace that x right there with f, which in our case is 2x minus 3. Now, be careful there because that's the square of a binomial. All right, you have to do 4 multiplications there. In fact, many students would write this down. In fact, you should write it. You should all write it down like this. 2x minus 3 times 2x minus 3. That's 4 multiplications. And whatever you get, you add 1 to that. So let me see. 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. And then I have minus 3 times 2x. Well, that's another minus 6x. And then finally, minus 3 times minus 3 is plus 9. And don't forget your plus 1 on the end right there. So you're going to end up with 4x squared minus 12x plus 10. There's the composite function. Now notice, just as it's set up above, here's f of g of x. You just keep it with red. There's f of g of x, and here's g of f of x. They're not the same, are they? They're not the same thing. Okay, what does part C ask you to do? It says evaluate f of g of x for x equals negative 3. Now remember, you've already worked out what f of g of x. Here it is right there. Look, there's your f of g of x. That was the answer to part A. So what you have to do here, what they're saying is put negative 3 into that composite function right there. So you could say that f of, if you wanted to, you could write it like this. It's the same as saying f of g of negative 3 is equal to, and because you've already worked out the composite function, just use that. So 2 times something squared minus 1, so you put negative 3 in there, and that's 9, 18. Look at that, you get back to 17. All right, so there's what they're expecting you to get back there. And the last part, excuse me, the last part, g of f for x equals negative 3, well, that means you plug it into the second composite function that you worked out. All right, so in this case, you would end up with g of, I like to write it like this. You don't have to, but I just find that it makes more sense what I'm doing here. So if I put that into the composite function, you're going to have 4 times negative 3 squared minus 12 times negative 3, and then plus 10. You type all of that into your calculator, everybody. Type that all in, and I'm pretty sure you're going to get back 82. All right, so it's a different number than the result for C as well. Okay. Now, I'd also like to point out there was another way to do C and D. I plugged them into the composite functions because I already had the composite functions worked out. But what if you did not have the composite function worked out first? Is it necessary to get the composite function to actually evaluate it for a particular number? And the answer is no, it's not. Let's come down here and look at number 2 for a second. Now, I think 2A, you should find that easy enough. That's not difficult. 2B is not difficult. I'm going to leave those for you to try. But I just want to show you a different way to do C right there, and D. Okay? Look at what this is saying. Let me put D over here, or C over here, sorry. It's saying evaluate f of g of x for x equals positive 3. Okay? Now notice I have not worked out the composite function f of g of x yet. Now I would have worked it out here in part A, yes. But what if this was a question on a test that said evaluate f of g of x for x equals 3? It's not really necessary to work out the composite. Let me explain what I could do. I'm going to take that 3, and I'm going to put it into the inside function, which in this case is g. All right? So I'm going to work out just g of 3, nothing more. And that's easy. Here's my function g right above. You see that? So that becomes 3 times 3, take away 6. Well, that's 9, take away 6. Okay, so I get back a 3. Now, That's the answer for g of 3. But that now, whatever that answer is, whatever you get back for all of that, you put that back into the function f. So here's your second step. Take the result of the first step, put it back into the function f because that's your outside function, and you actually work out what that is, and you're going to get back, let me see, 1 over x. Well, that's easy enough. That's just 1 over 3, which is 1/3. Now, that is the result of f of g of 3. Okay, and notice that I actually did it in two separate pieces. I did it in two separate steps. I didn't need to actually work out the composite of those functions in order to get the result of putting 3 into the composite. I didn't need to do that. And you could even do that for D right here, everyone, right? Take 12, put it into the inside function first, so put it into f. Whatever you get back, that goes into the outside function g. All right, so it might save you a little bit of work if you have that question on a test or on a quiz. And if you don't necessarily need to work out the composite of the two functions, well, don't. Just use this technique right here. Okay, so I'll stop there for today, composition of functions. Please try the examples on page 21. I don't think there's anything there like very tricky. So try the ones on page 21 right there. And they've got some more on page 22. They've got lots of composites here. So try those as well. Practice makes perfect, remember. If you have any difficulty with any of these, if you're not getting the same answers as what's on D2L, check your working, see if you can see where there's a mistake made. If not, well, you email me and you ask me about that, okay? So I'll stop there for this video, composition of functions. Have fun with it all, and I'll see you all later. Bye-bye.